Hi, Will Brewer here, HVACR Application Engineer with ABB. And in this video on adaptive programming, we're going to take a look at the comparison function blocks. To use the comparison blocks in adaptive programming, go to the functional blocks section, grab the slider bar on the bottom, click and hold to drag it over to the right. Here you will find the greater than, less than, and equal function block. These blocks use numerical inputs to output a Boolean true or false value. The greater than block compares the value of input A, and if greater than the input value of B, the output Boolean state will go true. For the output to go false, the A value has to become less than the B value minus the value of hysteresis. So here you can add a little bit of deadband so that way your Boolean state doesn't go true and false as the A value hovers above and below the B value. For example, if we grab our analog input 1 and compare that to a constant value of 5 and a hysteresis of 1. Now, as input A from analog input 1 goes above 5, the output will go true. But analog input 1 will have to go below 5 minus 1, or 4, for the output to go off. The less than block works the same, but inverted, as A is compared to B still. Only when A is less than B will the output be true. The hysteresis here is added to B. So as A goes below B, the output will be true. When A starts to be larger than B plus the hysteresis value, will the output go false. Finally, the equal block simply compares the value of A to the value of B. If you are using numerical values with a decimal point or fractional numbers, the input will round up or down to whole values to be true or false. For example, 7.5 will be rounded up to 8 if comparing to 8, where 7.4 would be rounded down to 7 comparing to B, or 8. If we plug in our values here to compare these in a program, you can do numerical values of fractions for the hysteresis as well. And we'll take the same analog input. We need to, and download to drive. And then run program. So currently our analog input is at 6.3. Compared to the value of 5, it is greater than, it is not less than 5, and it is not equal to 8. So if we increase our analog input, here you can see that 7.6 is rounded up to be roughly equal to 8. Now if we decrease our analog input, the greater than output is still true because we have not passed the value of the hysteresis, while our less than block has gone true because our input is less than our numerical value of 5. As we continue to go down, the greater than value block has finally gone false. Now let's increase our value back above the 5 to get our less than block to go false. There we have it. To add on to our comparison blocks, we could also add one more layer here by combining blocks from different sections. If we wanted to know only when the value of analog input A was not equal to our numerical constant, we could take our output to a NOT block and simply connect the two. Now, when we download and run our output, we can see that when analog input 1 is not equal to the numerical value, our output is changed to true. Now, if we adjust and set our value equal to our constant, we can see that when our input and constant are equal, our value is converted and is false. So that's one way to combine function blocks of different categories to get the output state you want. And that is a simple program using the comparison blocks. If you would like to learn more about adaptive programming, check out the videos linked in the description below. And if you have any further questions, feel free to reach out to your local ABB representative.